Hello, sixth graders. So today we're going to use what we know about finding the area of a triangle, finding the area of a rectangle, finding the area of a parallelogram to now find area of special quadrilaterals. And basically all that means is that if we don't know the area formula for a certain four-sided shape, because remember a quadrilateral is just a shape with four sides, okay? If we don't know an area formula for it, we can break it into shapes that we do know the area for, such as triangles and rectangles and parallelograms. All right? So for example, if I were to draw a shape like this, oh, that's a bad line. Sorry about that. All right. And this shape is what? What would you call this shape? If you were learning shapes in like kindergarten, first grade, what would you call this shape? This shape is a trapezoid. It has one set of parallel sides. All right. We do not at the moment know the area formula for a trapezoid. However, we can break up this shape into shapes that we do know how to find the area of. Okay? How do you think you can break this shape up into shapes that we do know how to find the area of? What do you think we could break up this trapezoid into? Well, you could break this trapezoid into two triangles and a rectangle, and I'll show you how to do that, okay? So we're given some information, so don't worry about trying to figure that out. Okay, we're given some information. We're given that this whole entire base is 18 yards. We're given that, okay? And we're given that this top base is 10 yards, okay? And what we are also given, okay, so if we break this up, okay, so look, I just broke it up into a rectangle and then two triangles. We know how to find the area of a triangle, okay? We know how to find the area of a rectangle, all right? Now, what is also given, and which you may not know what this means, but I draw a line like this and a line like that. And what that tells me is that both of these triangles are equivalent. They're saying that both of these lines right here, now they may not look it because of my drawing, but they are equivalent. So that means that both these triangles are the same. So if this whole bottom is 18 and this is 10, well, that means that this, again, if this right here is 10, then that means that this is 10 right here. From here to here. So then if both of these are the same, well, 18 minus 10 is 8. So 8 has to be spread evenly between this length and this length. So what is the base of both of these triangles going to be? Well, it's going to be 4. 4 plus 4 is 8. So this is 4 yards, and this is 4 yards. So now the only information, what are we missing to find the area of this triangle, these triangles, and this rectangle? What are we missing? Well, we don't know the height, okay? So that's also something I'm going to give you as well. Now, the height is 12 yards, okay? So now, with all of this information given, we didn't know how to find the area of a trapezoid, but we do know how to find the area of a triangle, and a rectangle. And we can use all of this information to do that, all right? So let's look at, and I like to label these shapes. So I'm gonna call the rectangle A. All right, so just this rectangle that we're doing right now. So area of a rectangle, remember, is length times width. I see a length of 10, I see a width of 12. So the area of A is 10 times 12, So A equals, what is the area of this shape? 120, and remember you need your unit, yards squared. So that's part of the area. We found this, so we're good to go. Now let's look at one of these triangles, okay? The base of this triangle is what? Okay, the base, and we'll call this B. The base of this triangle is 4, okay? So 4. What is the height of this triangle? The height of this triangle, if 12 is over here, it's 12 over here. Remember though, we cannot just multiply the base times the height to find the area of one of the triangles, okay? We cannot do that. We have to also divide it by 2. So B equals this. So what is the area of just triangle B? Well, 4 times 12 is 48. 48 divided by 2 is 24 yards squared. And if B is the same thing as this triangle, which we'll call C, well, if B is 24 yards squared, then C is 24 yards squared. And now we have found the area of all of these shapes. So what do you think we have to do with 120, 24, and 24? Well, we're going to add them all together, okay? So 120 plus 24 plus 24. Our final area of this shape is, 2 plus 2 plus 2 is not 4, it is 6. We get 168 yards squared as our total area. Now, some of you may be thinking something. Some of you may be saying, well, Miss Rothstein, let's go back to finding the area of this triangle, okay? Because what I did base times height, which, yeah, I agree with, okay? And then I divided by 2. And then basically after finding the area of this triangle, I multiplied by 2 again, or I added it again, which dividing by 2 and adding it again kind of cancel out. So here's a little trick. Okay, if this confuses you, do not worry about it. Just find the area of all separate things. But if you can figure this out, this may be a helpful trick. If you're finding the area of something and you have a triangle and then you have an identical triangle somewhere else in the shape, you can just multiply the base times the height and not divide by 2. And then that will cover both triangles. Because remember, an area of a parallelogram is base times height, and that is 2 triangles. So if you can wrap your head around that and see that just multiplying the base times the height of one triangle and not dividing by 2 covers both triangles, you can totally do that. But the thing you need to make sure of, okay, is that the triangles are equivalent. This line tells me that they're equivalent. If they are not equivalent, meaning they don't have the same base and height, you cannot use that little trick. All right, okay? So let's do one little example. All right, so let's look at a shape that looks like this. Okay, and we are given that this whole thing here, the height is 12 feet. We're given that the base is 5 feet. And we're given that this height right here is 10 feet, okay? Again, what shape is this? This is also a trapezoid, okay? Doesn't look like our standard trapezoid, but it has a set of parallel sides, All right, so how can we break up this trapezoid into two shapes that we know how to find the area of? Well, we could break it up like that. Rectangle, I know how to find the area of. Triangle, I know how to find the area of. So let's start with this rectangle. We'll call it A. What is the area of this rectangle? Well, length is 5, width is 10. We don't use 12 because 12 is the whole thing. So the area of this rectangle is 50 feet squared. Area is always squared, remember that? Okay, and now we have this triangle. What is the base of this triangle? Well, if 5 feet is down here, 5 feet is up here. So the base of this triangle is 5 feet. What about this height of the triangle? It's not labeled, but how can we find it? Well, the total height is 12, and this is 10. So we can do 12 minus 10, and it will give us 2 feet. So now that we have the base and that we have the height, we can do base times height divided by 2. And what is the area of this triangle? Well, 5 times 2 is 10. 10 divided by 2 is 5. So the area of this triangle is 5 feet squared. So now we have 5 feet squared plus 50 feet squared. Add them together. What is our total area of this shape? 55 feet squared. And that's our answer. All right, so as long as you're just breaking it down into shapes that you know how to find the area of, you will cruise through this section. All right, have a good day.